Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 4, Lesson 9, Writing Addition and Subtraction Expressions. This is not just simply solving addition and subtraction, although that would be pretty easy, right? I mean, that may be what you're thinking. This is actually writing expressions. And in some cases, it's going to involve numbers, and in some cases, we're going to use variables. So before we jump into that, we're going to do a couple of very simple examples to get us kind of warmed up, and then we're going to jump into the heart of this. So let's get started. Okay. 3 plus 5. Can we create a tape diagram that shows 3 plus 5? Well, I think we can. We're going to have 3, and then in a different color, I'm going to add on 5. We'll make that work for right now, okay? 3 plus 5, right? So that's fairly simple. Now, how would you look, or how would this look if it was supposed to show 5 plus 3? Well, then you'd have 5 red, right? 1, 2, 3, 4, 5, and you would add on your 3 black. But you notice that these two expressions are equivalent, because even if you put your 5 here and your 3 on the right, it doesn't matter if you put your 3 on the left and your 5 on the right, they are still the same size, right? And we know mathematically they both equal 8. So if you start here and count to 8, it's going to be the same. 3 plus 5, 5 plus 3, we're going to be looking at the same answer. All right? How can we show a number increased by 2? A number increased by 2. Well, if we don't know what the number is, you might be thinking, that's going to be really hard to show a number plus 2 if we don't know what the number is. Well, think back to what we've talked about with variables. We can represent any number with a letter. So let's just say A is our number, and that increased by 2, we could say A plus 2, or we could say 2 plus A, because of the properties we talked about in the last lesson, right? We know that we can switch when it's addition. It doesn't matter which order it goes. Now, can you show this with a model? Sure we can. Here's our A plus 2, right? Here's our plus 2. Or we could say our 2 plus A. Now, you might say, is that an accurate, like that looks like it's about 4. It's not necessarily accurate because we don't know what A is. A could be 50, A could be 1,000, A could be 1. But what we're showing is we've got a number here and we're adding 2 to that number. Or we have 2 and we're adding A to that number. What if we said, write an expression to show the sum of M and K? Well, an expression, again, doesn't have an answer. It's just a problem, right? So we could say M plus K, or because of the commutative property of addition, we could say K plus M. Those are the same thing, right? How about this? How could we draw 10 minus 6? How could we draw that expression? Well, first thing, I know I'm starting out with 10, so I'm going to draw that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my whole thing is 10. And then if I'm going to take away 6, I might gray out the 6. 1, 2, 3, 4, 5, 6. This would represent 10 minus 6. Could this also represent 6 minus 10? Could I flip it? No, there's not a such thing as a commutative property of subtraction. You can't flip it. 10 minus 6 is going to be 4, because that's what we would have left, right? 1, 2, 3, 4. 6 minus 10, you'd be going into negative numbers. You'd be actually going into negative 4, and we don't want to go there, right? Can't do it. That's not the same. Negative 4 and 4 are not the same. So, can we show an expression to show 3 less than a number? Well, again, if we don't know what the number is, we're taking 3 away from an unknown number, right? So we'll just say n for number, and since we're taking 3 away from it, we're going to say minus 3. If that's confusing, if you're thinking, why wouldn't it be 3 minus n? Well, think about this, 3 less than something. If it was 3 less than 10, you would say 10 minus 3. If it's 3 less than n, it's n minus 3. So you could temporarily put a number in there to help it make sense to you, as long as you make sure you use the proper variable when you go back. So n minus 3. How would we draw that? Well, again, we'd have our whole tape diagram. This whole thing is n, and then we would shade a portion of it, and we would say that that portion is 3. That's the part we're taking away. What would be left would be our answer, and we don't know what that is because we're just writing the expression. We're not solving. We need more information to be able to solve. Okay, how about another one? Let's look at the number c. We don't know what the number is. We're just going to say c. Subtracted from the sum of a and b. Well, first thing we're going to do, the sum of a and b is either going to be a plus b or b plus a. Either one works. They're the same thing. And then, since we have to find the sum first, then we will take away c, because it's c being taken away from that sum. So we've got to get the sum first, and then we can subtract c. So either one of those answers would be correct as long as you make sure that you have the sum first. And we know because of PEMDAS, we know you wouldn't take b minus c and then add a. Like, you know that's wrong. So as long as you have a plus b or b plus a first, you know that's what you're going to do first, and then you'll take away c. Okay, one more quick example, and then we're going to get into some of the problems here. Can we show c minus the sum of a excuse me, and b? This is one where it gets a little tricky. So it says c minus something. So we know we're going to start out with c minus. And then when we have the sum of a and b, we know that means addition. So, is this correct? In its current form, it is not. It looks right, but it's not. Because here's the thing. We're going to take c, whatever that number is, and we don't want to take away a or b. We want to take away both of them together. So we have to have parentheses here, right? Because if you just have c minus a plus b, order of operations, PEMDAS says you do subtraction and then addition. So you'd actually be taking c minus a and then adding b. So that doesn't work. So you have to have the parentheses there, right? Just as an example, if we said a is 1, b is 2, and c is 3, well, if we do it without parentheses, we'd have 3 minus 1 plus 2. 3 minus 1 is 2, plus 2 is 4. If we do it with parentheses, we'd have 3 minus 1 plus 2. 1 plus 2 is 3. 3 minus 3 equals 0. So you see that the parentheses change the answer completely. And since we're taking c minus the sum, it wants you to add those first before you subtract. So you have to have the parentheses there. Okay, let's look at some examples we're going to go through fairly quickly, and then we'll look even more in class. Okay, I'm going to go through these examples from Eureka Math pretty rapid fire, but you're going to have this video to go back to anytime you need it, and you can look at the examples. So write an expression to show the sum of 7 and 1.5. Well, we know sum means addition, so we could say 7 plus 1.5, or we can say 1.5 plus 7, same difference. Number 2, write 2 expressions to show w increased by 4. If you're increasing by something, you're adding to it, right? And then draw models to show both expressions. So here we know we have w, and then you increase it by 4. That's also going to be the same as 4 plus w. If I have my form here, or my tape diagram, I know I have w, and then this is going to be 4, right? I'm adding 4 onto it. You could also say 4 and have your W there added onto it, right? But just as long as you show that you have some number, whatever it is, W, increased by 4. All right, for number 3, it says write an expression to show the sum of A, B, and C. So we're adding those all together. So you could say A plus B plus C. You could say any variation of that. Blank plus blank plus blank. As long as you have A, B, and C and you don't repeat them, you could have C plus B plus A. You could have A plus C plus B. There's multiple different ways to do it. As long as you have all 3 letters and you're adding them, you're going to be good to go there. Number 4, write an expression in a model showing 3 less than P. So we're starting with P and then making 3 less than that. So we're going to have P minus 3. And then we might also show a model that shows this whole thing is P, but we're going to shade out and take away 3. All right, number 5. Write an expression to show the difference of 3 and P. Different problem here, right? It's the difference of 3 and P. So this time it's going to be 3 minus P as opposed to 3 less than P, which is P minus 3. Write an expression, for number 6, write an expression to show 4 less than the sum of G and 5. 4 less than the sum of G and 5. Well, we're going to say G plus 5, which is the sum, and then 4 less would be minus 4. You don't need parentheses because you would do addition first anyway, because it's on the left. You could also say 5 plus G minus 4, you'd get the same answer. Number 7, write an expression to show 4 decreased by the sum of G and 5. I'm going to write that over here. Now that's different because you're having 4 and then you're decreasing it by that other number. So you're starting with 4. So I'm going to say 4 minus 5 plus G, or G plus 5, it doesn't matter. But key thing here is, again, you have to add your parentheses because you don't want to do 4 minus 5 first. You want to get the sum and then take that away from 4. Okay, so I hope you're kind of seeing some of the small little details, like especially 6 and 7. G plus 5 minus 4, 4 minus 5 plus G, you need the parentheses. Okay, same thing up here with 4 and 5. P minus 3, 3 minus P, different thing. So you have to look at how they write the problem. Okay, I know that was a lot of information to throw at you and a lot of examples, but I wanted you to have a lot of examples to look at. We'll look at some more examples or some more questions in class, solve some more of these, and we'll talk about it more then. Thanks for watching. See you soon.